Okay, let's just jump right in. Today's explainer is all about the sheer, absolute engineering genius behind the Tandem Rotor system. We're going to use the legendary CH-47 Chinook as our blueprint to figure out exactly how these massive machines literally defy gravity. Honestly, it's a total masterclass in taming really complex physics with just brilliant mechanical design.
28,000 pounds. Let that sink in for a second. That's roughly the equivalent of lifting 7 mid-size cars all at once. This 52-foot-long behemoth can carry all that cargo internally inside a massive cabin that seats 33 people, or it can actually sling-load it underneath using this incredible triple cargo hook system. And when those rotors are spinning, the whole aircraft spans an unbelievable 98 feet.
So naturally, you gotta wonder, how on earth does a helicopter lift over 10 tons of weight without just, spinning wildly out of control or literally tearing itself apart under all that mechanical stress? Well, to answer that, we really have to look at the engineering approach. We're gonna break down the fundamental problems of flight and see how the tandem rotor system just brilliantly solves every single one of them.
The magic of lift.
So getting a machine this heavy off the ground comes down to the airfoil, specifically something called its mean aerodynamic chord. You see, instead of just being flat pieces of fiberglass, these blades have this asymmetrical, constantly changing curvature all the way down their length. As they slice through the air, that specific shape creates a dynamic reaction. It generates a perfectly smooth, incredibly powerful upward flow of air that physically supports all that massive weight. But to get that kind of lift, you need serious speed. 225. That is the frankly terrifying number of revolutions per minute these rotors are hitting during normal flight. Just picture it, 60-foot diameter rotors spinning furiously, churning the air to pull a 10-ton giant into the sky. The raw mechanical energy at play here is just staggering.
Section 2. Canceling torque. Tandem rotors.
Now, think about a traditional helicopter for a second. It requires a tail rotor, right? But honestly, a tail rotor is fundamentally kind of a parasite. It robs precious engine power just to push back against torque so the body of the helicopter doesn't spin out of control. A tandem rotor system, though, it completely ditches the tail rotor. That means it can use 100% of its engine power purely for heavy lifting. It's a real game changer.
So how do they pull that off? Simple, but brilliant. The front rotor spins clockwise, while the rear rotor spins counterclockwise. Because they're spinning in opposite directions, the opposing forces perfectly neutralize the torque. It is such an elegant physical solution. It keeps the aircraft completely stable, and it doesn't waste a single drop of engine power to do it.
Section 3. Synchronizing the span.
Okay, but here's the obvious question. If you've got two massive overlapping rotors, why don't they just smash into each other? Well, the answer is a total stroke of structural genius. The rear, or aft rotor mast, is mounted exactly 19 inches higher than the front mast. Plus, it's tilted at a 4-degree forward angle, while the front is tilted at 9 degrees. That brilliant geometry makes sure those spinning blades safely clear each other, even when they're violently flapping around during really intense maneuvers. But just having physical clearance isn't quite enough. They absolutely have to spin at the exact same rate. Let's trace how the power actually flows here. Air and fuel ignite in these incredibly powerful T55 turboshaft engines. That rotational power gets sent through transmissions that have one-way sprag clutches. Think of them kind of like the freewheel on a bicycle. They only let power flow in one direction. From there, the power feeds into the ultimate mechanical conductor, the combining transmission. Now, the combining transmission is basically the beating heart of the aircraft. It takes the raw power from both of those engines, applies a 1.7-to-1 speed reduction, and strictly, I mean literally strictly, locks the rotation rate of both the front and rear rotors. By mechanically linking them through this one single massive gearbox, the rotors are physically forced to operate in absolute perfect harmony. There is no room for error. And actually, this drive shaft and transmission linkage is so intrinsically connected that it doubles as a massive safety feature. Say one engine fails during a mission, which, happens. Well, the synchronizing shafts ensure the one remaining engine still drives both rotors simultaneously. Remember that sprag clutch we mentioned? It allows the dead engine to safely disengage without causing drag, while the active engine keeps the heavy lifter right up there in the sky where it belongs. Just to really ground this in some mind-boggling scale for a second, we're talking about two Honeywell T55 turboshaft engines, cranking out a combined maximum of over 10,000 horsepower. That is a ridiculous amount of power. It allows this tandem rotor titan to effortlessly haul a 10-ton load through the sky at nearly 200 miles per hour. It's absolutely astonishing performance.
Section 4. Steering a 10-ton giant.
So with all that going on, how do you actually steer the thing?
Well, directional control happens by physically tilting the entire plane of rotation for those massive wings. When the pilot makes manual inputs, it pushes and pulls on these complex mechanisms called swash plates. These plates dynamically change the pitch or the angle of the blades as they rotate. This effectively tilts the invisible disk of thrust in whichever direction the pilot needs to go. The flight controls here are an absolute masterclass in aerodynamics. If the pilot wants to climb, they pull the collective pitch to increase lift on all 6 blades at the exact same time. To move forward or backward, the cyclic tilts both rotor planes together. But here's the really cool part. To spin the helicopter on its axis, to yaw, the pilot pushes a pedal which tilts the front rotor to the right and the rear rotor to the left. Those opposing forces just effortlessly rotate this massive aircraft right in midair.
Now, obviously, flying at almost 200 miles per hour could be pretty exhausting, so the engineers built in an electronic assist. To stop the pilots from having to constantly fight against the wind at high speeds, an automatic speed trim system steps in. It slightly tilts the rotors forward or backward all on its own. This keeps the fuselage perfectly level and gives what's called a positive stick gradient. Basically, the flight controls always feel normal and predictable, which takes a huge amount of physical strain off the flight crew.
Because this tandem rotor system is just so incredibly robust, so well engineered, and honestly so endlessly capable, the CH-47 is projected to keep flying for at least 40 more years. I mean, think about that. It was first introduced way back in 1961, and yet its design is still the absolute pinnacle of heavy-lift aviation today.
So, with upcoming future upgrades pushing those engines to a staggering 6,000 shaft horsepower each, it really leaves you wondering, what impossible tasks will we ask this tandem rotor titan to conquer next? As long as there are physical boundaries to push here on Earth, it seems like this absolute masterpiece of engineering will be there to break them. Hopefully, this explainer gave you a solid grasp on how this mechanical marvel actually works. Keep learning, and I'll catch you on the next explainer.